So hello guys, welcome back to my channel Code Shiva, where I post about my DSA content each and every day, and today is day 17th of doing so. The problem that today we'll be solving is kth largest element in an array, which is LeetCode 215. So let's see what the problem really is. Now here the problem states that given an integer array nums and an integer k, return the kth largest element in the array. Note that is the kth largest element in a sorted order, not in the not the kth distinct elements. Okay, so what we are required to do is that we will be provided with an array and we will be provided with something as k, and we need to find kth largest element. Like if within this array, if we are to find the first largest element, the maximum element within this array, it would be 6. The second largest element would be 5. The third largest element would be 4, and like the thing is like that. So let's see this problem in detail. So this is an example, and this is an array, and we are given with the second largest element. We need to find the second largest, or maybe let's say third largest element within this array, and that's what we need to do. Okay, uh, let's let's say we are to find the third largest element within the array. How we'll be able to do so? The very first approach to this problem might be sorting. Okay, sorting, like if we first of all sort this array like 1 2 3 4 5 6, then we can just return the index. Like if this is the maximum element, we can, if we are given the third largest element, we will subtract, like wherever the, like we will subtract from n minus 1 minus k, and this particular index will be the place which will carry our, like, kth largest element, this element, kth largest element. So this is what will be, like, this is one of the approaches to this problem, and obviously depending upon the kind of sorting algorithm, we will have our time complexity. So in the worst case scenario, we go of n log n will be our, like, time complexity, and space complexity, obviously we're not using anything, so it will be constant space complexity. Okay, the second approach that the second approach that we'll have to look at this point. Okay, let me just erase everything that I've written over here. Okay, so the second approach to this problem, let's see if we can come up with a different approach. Yes, what we can definitely do is we can calculate a max element within this array. We can calculate a max element, and we can, like, every time, if like we are having k equals to 3, what we can do is we can remove a particular max element from the array, and after that we can again find the max element of the array, and we can do this for n time. Like within a loop, we can have a loop over here, and we can do about it, like we can do it about k times. But the time complexity will be very very bad, which will be like time complexity, it depends on k. So it will be like k of we go of k, and k times n, and space complexity, yeah, it will be constant. So this is the second approach, where we will be having a for loop and we can eliminate elements. The second approach can be eliminate largest element, k times. Okay, so even if like we have a sorted array, we are just popping out the highest element, and then we will be taking our maximum element again and again and again till k times, which will at last give us the maximum element as the kth largest element. Okay, let's move on to the last approach to this problem, which is the most optimal approach. In this case, the last approach is by using heap. So if you know about heap data structure, heap data structure is a kind of a data structure in which elements are it is like a kind of a tree data structure in which elements are stored in a particular format. Elements are stored in such a way that if let's say this tree can be considered a max heap if the top element, this is the top element, it returns me the max value within this whole tree. Like this particular element will have the maximum value within the tree. And similarly, if you want to, like, there are different types of heaps. So if you're talking about something as a min heap, if you're talking something about min heap, it will be opposite to max heap. What it means is it will store the minimum element at the top. So it will store the minimum element at the top. That's fine. Now, element like insertion and deletion within a heap has a certain time complexities, such as time complexity for entering something into a heap would be go of log n, and that's it. Like if we want to delete a certain element, time complexity to insert insert or delete anything within a heap will take a big of log n time period, which is obviously smaller than n. Okay, so what happens is we can use a heap data structure here over here, and through that we can solve our problem easily. Okay, so what we will be doing is, if we want to find out the third largest element within the array, what we will be doing is, first of all, we can maintain a heap of k elements, let's say priority queue, and it contains, like, priority queue is nothing but a heap. Okay, so let's take a priority queue, and we will be entering the first k elements of the array within it. Okay, so they will be 3, 2 and 1. So if it we will be taking a min heap, right? We'll be using a min heap in this problem. That means the top of the min heap always contains your minimum value. So this can be our top element within the min heap. So what we'll be doing afterwards is, since we have traversed the array till this point, till kth index, then we will start from k plus 1 index, and what we'll be doing is, if there is a particular element which is greater than our top element, then we will be substituting that element with the top element. We'll be swapping that element, right? So how we'll be doing it, we cannot generally like swap as we generally do. We cannot swap like that. What we need to do is, first we will pop out the smallest element within the array, and then what we will do is, we will take the particular element. Let's suppose I is at 5, so then we will have 5 over here, and then we will move forward. Let's say I will come over here at a 6, and since now here the topmost element will change, because 5 is particularly larger than 3 and 2 itself. So we will take the smallest element, and now the top of the heap will be 2, and obviously 6 is greater than 2. So again what we will be doing is we will be popping out 2 and we will be inserting 6 at its place. Now where is the smallest element within the array? It's 3. It will be the top of the heap. Again we will increment our I, and it will be going at the last index. And when it is at the last index, we can again see that the value of the last index is greater than the top within the heap. So what we'll be doing is we will be eliminating this top, we'll be popping out this top, and in place of that we will be having a 4. Okay, that's it. Now if we look at this particular priority queue, we can finally say our answer is at the top of the heap. Okay, why does it work? Why does the solution work? So this solution just works because we are taking basically a window. Okay, we are taking a window of like k elements, and what we are actually doing is if we want to find the kth largest element, we are looking at the most smallest element and we are eliminating that smallest element because we want the top largest largest elements within the heap. So we'll be eliminating those elements and we'll be getting rid of the smaller elements so that larger elements can come. So in this way, this priority queue will contain the top largest elements within the array, the top 3 largest elements within the array, since 3 is the value of k, and within that we will be getting the smallest value within that particular priority queue as our answer, because yes, since a, b and c are the largest within this array, and if a is greater than b and b is greater than c, then this is logical to say that c is the third largest element. So this is it. This is all I can say in our logical part or theoretical part. Let's discuss the time and space complexity. So the time complexity within this problem, when we are using heaps, particularly we are entering elements into the heap, and for like what we are doing is big O of n into log n time. So n log n will be the time complexity, and space complexity will be obviously constant because no, space complexity will be something. Space complexity will be k, because we are using a priority queue with size k. Okay, so there is obviously some space that we are using aside from input, and that's all there is to it. Let's implement the problem and see if our logic works. Okay, first of all we will be taking a priority queue. So to define a min priority queue, what we need to do is we will have to pass there is a certain way to initialize a min priority queue, and okay, so min, let's say min heap. Okay, let me take int n equals my n value over here. mm, After this we'll have to make a priority queue of k length and insert first k elements. so this is fine. Now min heap dot push nums of I. Now when this step is done, we'll be iterating through the leftover array and gather. Okay, int I equals k, I will be smaller than n, right? So at this point, if there is a particular number, if nums of particular I is greater than min heap dot top, if it is greater, what we will be doing is we will be replacing this top element with nums of I. So min heap dot pop. This way we can remove the smallest element which is at the top, and min heap dot push the particular element nums of I, and we'll be doing so till we reach the end of the array, and at last we will be returning min heap dot top. That's it. Let's see if our solution works. Okay, so my solution works over here, and this is a solution that I have written down. Let's see if it works for larger test cases too, and if it shows that it is optimal. Okay, so this is our code, and it is running even for larger test cases too. So that's it, guys. This is the end of day 17th, 16th, whatever it is. I'm just doing it every day, and yes, thank you for watching. If you're watching my video, yes, maybe there are very less people who are watching my videos, but I'm really thankful to you guys, whoever is watching. It motivates me to make more videos, and it motivates me to be consistent towards whatever I'm doing, and it gives some meaning to my work. So please support me, guys. It means a lot. And thank you. Log out. I really love you all. Bye.